So again, welcome everybody to our today's episode of Battery Spotlight. And we started already a little bit discussing battery production, which will be a big topic today. And first of all, I want to welcome Simon Voss as my co-moderator. And even though he's a co-host or co-moderator, the same rules apply for him as for every other speaker. He gets the chance to introduce himself in a 4-minute pitch. Before you start with this, Simon, give me a chance to introduce you with a short background. So you have an expertise in the battery manufacturing. You were the CEO of the 𝗕𝘁 factory or the 𝗕𝘁 facility. And within this time, you also set up a first battery pilot production line. So you have a lot of expertise there, but you changed your position completely. You started your own business and now you're on tour with the electric van, driving through Europe, talking to the important stakeholders of the battery ecosystem in Europe. And I think I don't want to talk more about the expedition tour because you will do this right now. So you have 4 minutes. The floor is yours.
So I want to share some insights from my tour and what I'm doing there right now. But first, let's have a look at where we are. So next slide is talking about what is going on. And 2 years ago, we saw like big announcements. The fact that you see on the left-hand side, this is this number here, in 2023, 50 billion. That is the contracts that Northvolt had secured, which allowed them to scale their business. 2 years later, we see a huge decline down to the insolvency, and also other companies have their problems at the moment on scaling their gigafactories. So I set up for a mission to understand why are Asian players just pushing through with their 5-year plans, but companies in the EU and the EU itself are kind of running in circles at the moment and not having the feeling to really make huge progress. And we are on the mission to fulfill the requirements that we see in the battery passport, and I will pass those slides later on. And the question is if even we European players will meet those requirements. So as I said, I wanted to find out, and because I was not certain if I think we have the competences, but the question is, how do we push through this innovation pipeline? So there are, besides the technology part, 2 other players involved, and that is the finance industry as well as the government. And so I'm talking to 3 people on this tour. That is industry, finance, as well as politics. And I want to share some impressions of my tour with the following slides. And this is the video that gives you an impression. So I've traveled over 9,000 kilometers, almost reaching 10,000 kilometers right now, visited manufacturers, machine suppliers, quality inspection suppliers, charging infrastructure innovators, etc., to really make up my mind of if those PowerPoints that we see at conferences are just talking or if they are really delivering value. And what I have seen so far is that we do have the competence. I see it, but there's one big issue, and that is that we need to connect. And that is also the reason why I decided to continue my journey, visiting more people. This is just the picture of today from Custom Cells, just some impressions here. And to circle back, this is the reason why I also started collaborating with TraWeBa, because this networking aspect really needs to be brought to the next level in order to build the European battery ecosystem. So yeah, if you have questions about this, I just gave some impressions. Of course, this is way too short to give you the whole extent of it. But then yeah, please state your questions in the following. So really short pitch, and I think I met the 4 minutes.
Yes, you did, even with 40 seconds to spare.
Okay, so we can keep that for some remaining words. Yeah, so some findings, what I think, how we can break this innovation barrier that is lying over us right now. I think we need to talk about regulations. We need to build trust, to talk to investors, very importantly, to focus more on the technological part of the process itself, because battery manufacturing is really complex and we need really shop floor expertise. And I think that is to some extent still missing. Today I saw a lot of expertise and this gives me hope. So yeah, I'm saying that I'm open to questions, and yeah, let's collaborate together to bring this industry to life.
Perfect. Thank you very much. Is there already a question from the audience? Maybe Simon, let me ask you one question. You traveled already to quite a handful of companies. What is your impression? Because I get really mixed feedback. Sometimes, even if you're attending conferences, there's companies claim that we have a good chance that we can compete with the Asian companies, and other days the prognosis is really bad, that we will not manage that we will never be able to set up a battery production in Europe. What is maybe just I know it's a really big question. You can talk hours on this, but maybe really quickly, what's your idea? Or
the simple answer to this is we are really good at making batteries, but not on scale. So this is the key takeaway. We know how to manufacture batteries, but scaling this to the gigafactory level is not something we have encountered yet. And this is what we really have to work on and to prepare for.
May I please ask a question? This is Christoph from
Hi, Christoph.
It's a really important question. We have what you're highlighting right now, the gigafactory and the volumes aspect. As we all know, there is the Pareto, which is the 20-80 rule, which means that for gigafactories, you need 20% of the applications will cover 80% of the volumes. And the 80%, we are not in this situation yet in Europe. We don't have that type of volume. So why are we building gigafactories? We should be building organically. We should be building the 80%. We should be building the 80% infrastructure to be able to actually scale up all of what you are saying. The research and development and the things that we have in the pipeline are really interesting. And what we are failing is the scale up capabilities. And what we need is to have flexibility in the application field. A gigafactory blocks you on a form factor for 10 years.
That's true.
And we don't need that. What we need is...
I would disagree with that. I think let me address your question, because of course, if you look at the current market demand, we don't see the big demand. We have overcapacities in China, like those lines are running on 50% at the moment. And yes, this allows them, and this is also politically incentivized, to push their battery cells with a dumping price on the European market. We are at $50 per kilowatt hour at the moment, or even below. And this is not allowing a buildup of battery capacities sustainably here at the moment, or at least challenging it really, really significantly. But your question was that we don't need that capacity. I would disagree. We need that capacity, and we get it at the moment from Asia. So if we look ahead,
I think we need to review the gigafactory model. I don't believe that we need to have the coating operation together with the packaging operation in mega scale, in giga scale. I think we need to have the coating operations which are separated from the packaging operations. It makes no sense to have the initial plan that you showed was roughly 60 to 70 gigafactory projects, which meant that you had 60 to 70 times coating operations. That we don't have that capacity in Europe. We have coaters everywhere, and we have mixing capabilities, but we never had this capability to build up 60 of those capabilities, and we don't have that in Germany. The people that can operate those things are people that taught me. I'm 65 years old. That taught me the business, the coating business, and they helped the Chinese to build up their capabilities. What we need, really, think about it. A gigafactory is coating up is a lot of our a lot of different capabilities and competencies aligned, which really pay off only if they have a very large scale, and which is paid by the farmer.
I'm sorry, and that is for every speaker, when my hand goes up, that means that we're running out of time. And
so I will introduce myself shortly and my company. So my name is Lukas. I'm in the battery field for more than 10 years now. Started my battery career at BMW, planning module and pack lines in the States, in China, in Germany, and in various cities there in Europe. Left the company 2021, founded or made myself an entrepreneur, and then I founded the Limited Lab, the German LLC form. And what we do is we are called like consultants, but we are operative partners. We partner with the project leaders, top management, and the operative level in getting the projects up and running. If there's a gigafactory going to bust, or if the projects don't go quite fine, we are the ones that get called, and we go on site and try to get it fixed. And we did more than 50 big lines in total. And if we combine every little strategic project and baby technology review, and it's more than 70 in total for more than 45 customers. Those are the OEMs, the tier ones, tier twos, so down to the component manufacturers, the equipment manufacturers, and more. Those are our customers. So, but I would like to get to the content. So how to really be successful? Of course, 4 minutes are quite short, but what to do? First, I think it's very, very important to understand interfaces and perspectives. You need many, many different people. You need a lot of skills to get a gigafactory up and running, and not just a gigafactory, even a small pilot line. And the most important factor is you need to understand the interfaces between those people. Usually 80% of the issue is not technology. This comes quite fast after that, behind that. However, it's always leading people together. So complete different people with complete international backgrounds are needed to look into the right direction and to work together. Second, you need to understand different perspectives. The customer versus supplier situation. Line builders need to understand that their customers don't make money with their projects in Europe. It's very hard to make money with cell production. There are a few applications, high performance applications, that are profitable. Most of them are not. The big companies cannot make money due to the price pressure coming from Asia. Second thing is product development versus industrialization. Many companies, and Northvolt could be one of them, that didn't have the focus on production and operationalization. They have big R&D departments, and not talking about Northvolt. However, a lot of small startups have a lot of great ideas how to improve the product, how to find new chemistries and more. But the products, especially modules and packs, are not designed to be manufacturable. And a lot of people underestimate the complexity of industrialization completely. And I think we really need to get some more front loading in there. And the next point is in development, the product benchmark develops quite fast. So if you really want to be successful, you need to be able to adapt your KPIs during the development process. And you cannot run the product from beginning to the end without having them adapted through all the process. And the third one is about organization and how to handle all of this. Because what I usually see is people stop planning during the project because they learn that their timelines and their procurement plans and everything. Yeah, please. Okay. All their plans need to be adapted on a weekly basis. And after doing this a couple of times, people stop replanning. And that's a very, very severe issue. Because as soon as you stop replanning, then everything will just happen randomly. But this happens here and then. When it gets stressful, when it gets very, very changey and volatile, you need to define and maintain your project structure. You need to stay within your communication channels and understand how important it is to lead people and not just getting everybody fuzzy and just run around and try to solve issues and the first issues coming into their mind. And the third is everybody needs to be ready to adapt to changes and be aware of changes and not to fight against them. Because if you try to fight against a change which will come, you will not be prepared, and it will have a very, very severe impact. Of course, that's just the surface. If you dig down, you will learn about technology skills and experience and technology ramp up and so on. But those are the most important points.
Yeah, thank you, Lukas, for elaborating us. And of course, this discussion on battery production can fill an evening, and approach us if you want to know more, especially from Lukas, who has a lot of shop floor experience. So question to all of you, is there a question towards Lukas? So if not, I would like to pick up on the question that was raised in my Q&A, and that was, do we need gigafactories in Europe, and could they be economically viable, Lukas? Because you see the performance that is at play at the moment, right?
Yeah, from an economic perspective, of course, we don't need them at the moment because it's quite cheap, and all the OEMs are quite happy that they can purchase the cells super cheaply from China. However, regarding geopolitical resilience and more factors, I think it's very important. From my point of view, the order needs to be different. It's not a good idea. The point is, if you don't plan on a gigascale as a big consumer, it will be too expensive to be competitive. If you scale on a gigascale, the first step, you won't be able to launch and to ramp up fast enough to burn down the scrap rate, and you will need a lot of money. This is what happened to Northvolt. So I think it's important to start small, but then scale fast if you want to be successful. I think the issue is that the total money you need at the very beginning is so high that you won't find many people, many organizations that can afford it in Europe. But I think it will be relevant. I think we really need to establish this kind of skill set, and I'm absolutely sure that we can do it. I saw so much progress the last year regarding process knowledge, process technology, at OEMs, at the cell manufacturers, at line builders. It's just a matter of time, but at the very end, it will be an economic and a resilience-based decision, and we'll see what the result is going to be. But I'm quite sure we will see European gigafactories.
Is there another question? When do you expect, Lukas, those gigafactories to be operational? I mean, it's hard to pinpoint a year, but are we away 1 year from now? Is it 2 years ahead? In general, when do we see first success stories?
And there are 2 or 3 gigafactories that can come quite fast. While ACC, PowerCo, Cellforce is just 1 gigawatt-hour, but that's giga as well, which could happen at the end of this year. For new plans, completely new projects, I think it will take more than 2 years. So we can see a few fast, but most of them will take some time from my point of view.
So my name is Thomas Freudenmann. I'm a CEO of EDI, and EDI is Engineering Data Intelligence. So the name is program. We are semantically linking the data and providing AI solutions for support the decisions or automate processes. And we are working with EDI in different circular economy industries. And since 1.5 years, we have a topic also for battery recycling. It's a founded project from the German government. It's called 𝗕𝘳𝘁𝘁𝗃𝗁𝗃. There are also battery producer involved. It's EAS battery from Nordhausen aus Germany, but also recycling companies, Remondis, battery life cycle, the daughter of Remondis, it's battery life cycle, BLC, and also partners from Fraunhofer and so on. So what I want to say is how can AI support the whole process? Also, we hear a lot about quality issues and scale up the things. And here just a few words to the project idea. So we talk also a lot about production, for sure. It's important, but also from the EU government, we get also the regulations that we have to recycling the batteries. And also here we have to see that the vision and the reality, it's not the same. Yeah? So if you really talk about recycling on a horizontal level, that means that at the end you can produce again new batteries. I will say there are also a lot of processes really, we have to establish these processes, and here we also have to use different kind of solutions. And one other thing, it's I think all of you know about the battery pass, about the digital product pass, which it's called in general. I think that's a really important thing, that we get such much information as possible. But also what I can say is, for different steps in the life cycle, that could be by for usage, it could be in the work. Yeah, if you go to the workshop and you want to repair the car, or you want to recycle it or reuse the material, so you need different kind of information. So that is what I want to say. There is no one battery pass with all information. So that is a dream maybe, but it will not happen. But also what I can say, it's battery pass could be a good starting point, and that is exactly what also EDI is doing in this 𝗕𝘁𝘁𝗃 project. This is a view of our digital twin, which we established for, especially for this recycling process. And from EDI perspective, we always provide this kind of AI-based hybrid models. That means we include also the expert knowledge, which it's also here in Germany already available. So many institutes, Fraunhofer, IKTS, which is also involved in this project, makes a lot of nice research work on these battery topics. So this is always a combination of algorithm and of the knowledge. And a starting point, it's always, I mentioned, you have the battery pass there, you have some information, but in a specific process, for example, on this LFP recycling process, you need additional information about the battery. You need about the jelly roll some information. You need about the detailed chemistry information. There you can use also camera techniques. You can use other sensors, and we are doing sensor fusions so that you get a holistic view on these things. And then during the process steps, we could provide as well different, I will say, specific informations which you also can transfer to different players. So we already hear as well that not everything has to be in one factory. You can also transfer the informations. So this is the idea also about this product pass, that the informations can be easy shared. And at the end, what we are also providing here, it's a kind of self-learning approach. That means also with AIS batteries, we really want to reuse the material which we have in the battery for new production. And also that's our target parameter. It's that we reach the defined quality for the new batteries with the recycled material. So that's really rough explained what we are doing. For example, Omron is also involved in this project where we have these digital twin solutions, where we have image recognition for the cells, where we get out this information. That was my pitch. So if you're interested, we also have a deep dive in a few weeks where we go a little bit more in detail how we are using the AI solutions and so on.
All right. Thank you very much. Is there a question from the audience up front? So you just mentioned it on your last slide. You already are working together with, is Omron your customer or partner in this?
Omron is a partner for automation, also for this recycling process.
So are there already customers or partners in the recycling space that you can name, which allow you to a little bit more practically explain how you integrate your solution in their daily operations?
Yeah, so as I mentioned, the daughter of Remondis is also involved, BLC, and they have this kind of recycling line, but especially for LFP, it's the aim of this project to also to go until the jelly roll, so that we disassemble the jelly roll, that we separate the material really also in a manual way, so that we have different approaches to get out the active material. So it's with chemical processes and hydro. So it's a mechanical way also to do it. So we challenge also these different ways, and for different battery types and chemistries, different solutions are helpful. And that's exactly what we want to decide if we get this battery on the table.
So what you're talking about is the sorting process before the pyro or hydrometallurgical recycling process, correct? Where you especially act on.
And as well to understand what happens in this recycling steps. So what kind of quality we get out. And so, for example, also you can see already that the size of the parts are different, and how much energy you have to bring into the system that you get it in the right dimensions and so on. So that's
Okay.
also to understand really how to reuse the LFP. LFP, it's a material, so also it's a little bit driven also from the EU regulations that you really, if you run these gigafactories, in the beginning you have a lot of waste cells. That's a nightmare for process automations. But if you then have also a good way to reuse this output from the battery from the gigafactories, then it's also a possibility to fulfill these EU regulations. So that's also the idea. So not really the used batteries which are coming back in 10, 20 years. It's also about it's hard to say, but it's also about the totally new batteries which not fulfill the quality issues in the production.
Okay, so
So I'm Michal Kotzé. I'm from Incipientus. I'm one of the co-founders. What I'm presenting today is our technical solution. It's an in-lice process rheometer, or a viscometer, for continuous and real-time battery slurry viscosity measurements. So the problem we solve for the battery industry is basically that when you have poor slurry viscosity control, that leads to inconsistent electrode quality or material loss during production. And since the battery slurry mixing is one of the first stages, it's quite crucial or critical in it, getting this step right the first time, because it will have a run-off effect if you look at our production process. So it's quite crucial to get rheology right first time. So if you have poor slurry rheology, it can degrade the final battery performance. For example, reducing energy capacity, lowering the overall efficiency of the battery, shortening the lifespan, or increasing the internal resistance of the battery. How they measure the viscosity, since it's such an important parameter to control, it's actually quite crazy to think about it, but today they still use offline viscosity measurement tools to take samples from the process and do analysis, and then come back and do adjustments to the process. Drawbacks with offline techniques, there's numerous, but here's just to list a few of them. So you're not measuring in the actual process. So when you take the sample away, you have some effects that can happen afterwards with the sample, because it's different to what's actually running in the process. The sampling frequencies is very small, so it can be every 60 minutes, 30 minutes, or even several hours. You have time delay on your analysis, that takes time, so it's also labor intensive. And all these effects have a run-off effect where it increases cost, time, and of course, making your decision-making a lot slower. And of course, if you can catch the deviations earlier, you can make better adjustments and have better control on your process. And the Incipientus solution, so we provide an inline process rheometer, which is continuously monitoring the rheology during the mixing process or during production. So the benefits of this system is you're actually measuring on the actual process conditions. So what's going in your tube while it's flowing, you have immediate feedback. This will lead to, of course, better consistency and uniformity in the final product. When you can optimize your ingredients usage, because you have feedback in real time, it can lead to reduced waste and of course not reduced efficiency, increased efficiency. And then you have better final battery performance. And then just to give some information on the technologies based off medical ultrasound, it's the same technique that's used to see inside the human body. So we took that technology and applied it to the process industry, so we can visualize the flow through the tube. And so we're not in contact with the slurry at all. So it's non-invasive, and it's pigging friendly. And of course, after many years of research, we can use these images to get the consistency or the viscosity of the product. I mean, it's applicable to food products, sauces, cosmetics, anything that's flowing in liquid form. And then on the right-hand side, I have just put a nice example, of a installation in a factory, how it typically will look like. And that's it. Thank you.
Perfect. Thank you. And perfectly on time as well. Thank you very much.
I felt like I was rushing a bit.
Chris, is there already a question from the audience? Otherwise, Michael, maybe you could, we talked already about the gigafactories in Europe. Maybe you can shortly comment, because I see there's already the first question from the audience, but maybe you can comment shortly on how difficult and important is the upscaling process for slurries?
Yeah, I mean, I'm not a battery expert, so I'm going to be honest. So we provide the instrumentation. But after speaking to numerous clients that we're currently working with, some of them are in the gigafactory world, it is quite a critical component to have your viscosity right and in real time to increase efficiency and overall quality in the end product. Yeah.
Perfect. Then, Luca, just unmute yourself and you can ask.
Yes. Yeah, thank you very much. It's very cool that you're trying to optimize the first step, or one of the first steps. And my question would be, it's cool that you can measure it online and in real time, but you also provide a recommendation or active parameter adjustment in order to reach optimal slurry parameters, or is it something that is left up to the producer still?
That's left. So what we provide is we provide you with the flow curve. If you're familiar with rheology, you basically have a shear stress versus shear rate. We provide you with a full flow curve, and then you can pick your shear rates that you want to monitor, and then you can do your limits on that and do your controls afterwards. Yeah. That's maybe where the AI fits in, Thomas, where you can take this measurement information and have some fancy control loops, adjusting the process. Yeah.
Thanks. So yeah, again, going back to the battery production, right? And I kind of start the pitch like everyone racing to build gigafactories, right? But making them profitable is entirely different challenge. And we all from beginning of this talk hear about Northvolt, Europe's biggest battery startup, which filed bankruptcy after raising over $15 billion. And what was one of their biggest problems? That every third battery they were producing was unusable. Despite years of engineering and industrial ramp up, these high scrap rates made the business unsustainable. And here is Northvolt may be the headline, but the underlying problem runs across the entire battery industry, which is scary. And if today one wants to build a gigafactory, they can expect to literally waste up to $2 billion a year. So we want to understand why is this happening? Because battery production is incredibly complex. It involves dozens of machines, materials, process parameters, and all of this operating across multiple steps, across multiple time scales, and across all of this process, we are generating terabytes of data. So let's say what happened to all of that data? It would be unconnected and is largely ignored until something goes wrong. And in 2025, in the age of AI, the battery industry remains data blind. So we come here as Accellion, and we are here to give battery production the intelligence that is missing. So that's why we are building our product, which called HANS, our highly adaptive neural system, which is the first intelligent data orchestrator platform and focus just on battery manufacturing. So HANS can access to all the important parameters of the production. So in this case, they can watch every process, listens to machine, learns, improves the yield, and everything happens in real time. Let's say, how does it do it? By unifying multimodal data. It can work with images, sensor data, machines, logs, videos, and they all combine them into one uniform AI orchestrator. So what can happen as a result? hopefully fewer bad batteries, which means faster optimization, waste reduction, and saving hundreds of millions. So we are saying what truly sets us apart here is that our product is designed by and for battery experts. And it is not just about another generic solution. Every decision engine inside Hans is trained to reason with specific battery domain knowledge. It's multimodal, understand all the complex interaction in the production, supporting process engineers to find clarity, and that's why it works. So the market is already $20 billion and is set to double by 2030. So the battery factories cannot afford to fly blind anymore. And how we want to sell that, we plan to roll out Hans as a B2B SaaS, or what we call it as Hans as a service, with a setup fee recurring license and a retainer, which enable battery manufacturer to stay flexible in all future constellation of chemistry and production processes. So we reach out to more than 50 industry experts here, and they express a clear need to have AI in their production. So the current battery software has players in monitoring, controlling, and analytics, and our mission is to connect and enhance. So we have one single goal: make Europe a battery leader. So our team is Lukas, which have a lot of experience in building a scalable software, Sebastian with a strong background in AI and physics, and me, Fuzhan, complementing the team as AI and battery researcher. We are an early stage of startup with ambitious goal, and right now we are focusing on validating our product. So if you want to see what Hans can deliver, this is the moment to collaborate. Let's talk together and make Europe battery factories intelligent and profitable. Thank you.
Fuzhan, thank you very much for the pitch. Really inspiring. Me as a former battery researcher and also coming from the battery manufacturing background. Where do you get the sensor data from? Really short answer, because we don't have that much time, but I think this AI-driven approach is good, depending on the quality of data that you receive, correct?
Exactly, that's true. I mean, that's the whole problem, right? Because the problem of the industry is they are having lack of unstructured data. It's fragmented. They come from different vendors, protocols, etc. And then we are also missing machine-to-machine translation most of the time. So that's why we are going from data-first approach and not directly from AI approach. So what we want to do is to unify all this data, and then once it's unified, then you can find intelligence inside that, right?
Okay. And
where you can find this data is, of course, battery production lines. So that's what I'm saying. If someone wants to see that, we need to connect.
Yes.
Let's have a word about the outcome if batteries are not well produced and they show thermal runaway. So I think I don't have to go in too much detail. That will happen if we see a thermal runaway. Of course, we have a great release of flammable gases coming out of the chemicals inside, and these flammable gases intend to explode if they are in such a concentration that they have explosive mixtures, and if they are in a confined space. And of course, this concentration will increase in the case that you have multiple of destroyed cells, which is an effect of the thermal runaway. So not going too much into detail, you can imagine if you have a container installation, for example, and you start this thermal runaway, you get a certain release of gases and explosive mixtures, and the result is seen many times around the world. So such container solutions had a big malfunction, big explosions, destroying the structure and rupturing by pressure. So these quite weak pressure-resistant housings are dangerous for people walking around or being around. And for that reason, we look for a solution to release the pressure, which will occur significantly after a deflagration. And for that reason, so-called explosion vents will be installed on the housing of such storage systems, and they will release the pressure to the outside in a safe way. So we have developed different concepts to size these so-called explosion vents on top, for example, on such container solutions. And we are supported by explosion standards which are available at the moment, because we are facing nothing else than a so-called gas explosion. And the systematic is called gas explosion venting. And so several surroundings, several setups can be considered. Therefore, different results will occur, which means you have installed more explosion vents or less. In some cases, these also need to be installed on the side because you're stacking these containers one over the other. And for that reason, you have a so-called side venting. So what is the option, or what is the physics behind it? If we follow the UL9540A, we have to analyze what is coming out of a cell because of its chemistry. When we know the explosive gas air mixtures, we can do the sizing for these explosion vents according other standards like NFPA 60H, which has a lot of equations behind to size it. On the other way, of course, we go the road down and do explosion prevention. So if we measuring an uncomfortable amount of gases, we can switch down cool systems and try to prevent that more gases are evaporated. But this is prevention, and this is constructive explosion protection. So what is now the findings that we saw during many tests that we have done on such systems? I have a short video. Of course, it's time consuming, but it explains quite a lot.
Explosion protection. Today, we're bringing this expertise to battery energy storage. 3 product series uniquely engineered for modern BESS applications. The BESS core venting series sets the foundation.
So that's a standard solution for outside application, just venting the container.
To match your best design. Experience breakthrough innovation with our BESS Smart Venting series. The integrated Targo vent principle safely redirects the force of explosions upward.
So now we direct the explosion to the sky for people walking around avoiding injuries.
Meeting the needs of space-efficient, stacked BESS installations. REMBE presents the BESS Premium Venting Series with BESS Q-Vent. This advanced flameless technology eliminates external flames while minimizing pressure and temperature effects, making indoor installations safer than ever before. Partner with REMBE, advancing BESS safety together.
Okay, so you see here different solutions, which I can explain later on in the discussion. So you need different technologies. So if you see here what is coming out of a container during the explosion venting process, you see a quite long flame duration, even if this is an explosion. And of course, this is not possible doing inside a building. And for that reason, we have a so-called flame arrestor element, which is installed underneath the explosion vent. And then the explosion will be quenched and you see no flame coming out. And even in the nearer surrounding, no dangerous effects happen. So that's our solution. And I just jumped through it. So we have 4 steps: analyzing the chemistry.
Time is over.
Yeah, doing the study, doing the calculation for the vent, and install it. So, and that's all.
Okay, that was quick.
Yeah.
Perfect. Yes. I knew he informed me that he had 19 slides. So
yeah. So I jumped through, and so maybe I
close.
could shorten it in the discussion then a little bit.
Yes. And yeah, we are almost reached our 1-hour goal for this event, but I think a quick question to Roland is still possible. And maybe from my side, just really quickly, how often will this venting be needed? Do you have some numbers on that?
So we see about 8 to 10 events per year where really strong thermal runaways happen. You can see this on different platforms all around the world. And if you do not proper venting, you destroy the unit, and this lead to very long downtimes for the entire energy storing systems. So it's not seldom, it's regular, I would call it.
10 events counted for how many battery storage systems?
All around the world, it's a lot. So it's not that it's done every time or around the corner, but when it happens, it has a very strong impact on the large field installations.
Yeah. So we